everyone. Today, let's talk about music.
Particularly music popularity classification.
Now, some of you might be wondering, what is music popularity classification?
Music popularity classification is the process in which we utilize musical analysis, which is the analyzing of the features of music, to understand what truly makes music popular or not.
And we analyze features like tempo, which is how many beats there are per minute, acousticness, which is whether the track has any vocals or not, and danceability, which is how danceable a song is.
And music popularity classification is utilized in all sorts of industries. Companies, record labels, and artists all use music popularity classification to understand if the songs are truly popular or not.
Now that we understand what music popularity classification is, let's talk about machine learning.
Machine learning?
Yeah, what is machine learning?
Well, machine learning is the process in which we use algorithms to train a computer to analyze big data and make predictions upon that big data.
And in our case, we utilize machine learning to perform music popularity classification.
And oh boy, what a process that was. But how did we even start?
Our research journey started at SURI, which, as previously mentioned, is Farmingdale State College's Summer Undergraduate Research Institute.
SURI was a completely new dynamic for us.
And it was a completely new field, and we learned many new skills.
And it was amazing, it was awesome. And we went through our field with our mentors, Dr. Xiaojin Ye.
And Dr. Nardeen.
Thank you very much for that. And through SURI, we learned how to analyze machine learning and big data to make those results.
Yeah. And at the end of SURI, we were able to discover 3 new features and find a new appreciation for research.
Thank you very much, our professors. You're awesome for helping us through that. But we didn't just stop there. We continued on.
We continued our research in fall 2023.
And in that, we decided to extend our research. First, we had to solve some of our issues that we faced during SURI.
After SURI, we realized our data set of 10,000 points wasn't large enough to create any reliable scores, and we needed reliable scores to create strong models.
Thus, we decided that we would collect 100,000 data points. That was 1 point per second, 100,000 seconds, 1,666 and 2/3 minutes, or 27.7 hours repeating. And oh boy, that had to happen without fail.
Yeah, and failures did happen.
It took 4 days and how many hours more to get that all? And oh, moly moly. It was like watching paint dry. At least those who research animals can watch them play around. Oh.
Dealing with that issue, we moved on to our next issue.
Which is binning.
Now, statistically speaking, some of you probably don't know what binning is.
So we'll explain it with a thought experiment.
Imagine you're filtering apples.
And your task is to decide if the apple is tasteable, sellable, or toss it in the garbage.
That would mean you have 2 bins, sell and toss.
That right there is what binning is.
It's crucial because now imagine instead of deciding whether the apples are sellable,
you had to decide upon the price.
and each bin is 1 cent of a difference.
You'd have thousands of bins.
And the warehouse to store those bins would be bigger than a football field.
Completely overwhelming. I'm overwhelmed right now imagining it.
Yeah, and the same can be said for the AI. If we give it too many bins, the AI can also be overwhelmed.
But let's not pity the thing. You know how devious they can be.
Yeah, because if we don't give it enough bins, the AI will just toss randomly, resulting in unreliable scores.
At that point, it did its job.
But not really, because it would give unreliable scores. And after dealing with the binning issue, we moved on to our next issue.
Which right there is oversampling.
Yeah, after analyzing our data set, we realized that not many songs were actually popular. So we had to duplicate the popular songs to create a greater emphasis on popularity.
And through that, it's like teaching a child. You must put the dishes in the sink after dinner. Emphasis on popularity, not on, oh, all songs are unpopular.
Yeah, fixing these issues wasn't without any challenges.
Through that, we had to deal with the fact that we lacked money. We lacked the big servers that other developers and researchers had.
Yeah, and the analysis were very hard and time-consuming, and our schoolwork made conflicts with our research work.
But we were determined. We had our hopes to succeed.
And we wanted to prove to ourselves that we were capable of this.
To leave a mark in research and academia that we as undergraduates were able to accomplish this research.
Yeah, and as if the universe didn't want to let us have it.
It was horrible. All of our data was invalid. It came out improper because of a single overlooked bug. We were completely, utterly hopeless.
Yeah, and this came just in time when we were planning or sending our findings to a conference.
But even in that dark hour, even in that moment of hopelessness, we had our determination.
And with our determination still strong, with our spark still ignited, we continued and sought after re-education.
We reanalyzed our scientific process.
And reread and reanalyzed all the previous research papers. Now, although our research journey didn't conclude the way we intended it to, we were able to gain some very valuable outcomes out of it.
We gained practical experience, understanding how to actually design these systems. It was amazing.
And we were able to gain critical research skills like process modeling, paper analysis, and big data collection.
And we're not just stopping here. In this summer, we're going to plan to continue our research to prove that we were able to do this. And then in the future, we will try to submit our paper to a conference. Thank you, everyone, and have a wonderful evening.